Hello everyone. In this video, I'm basically going to explain why computers equal beauty. All right, well really what I'm going to try to do is show how computers can be a path to achieving beautiful things. And it's part of my lecture series for a digital design course where you're using the computer to design things, specifically architecture is what I teach. Now, the reality is beauty is a very philosophical term. I'm not a philosopher, maybe an armchair philosopher, probably more accurately, an IKEA chair philosopher. It's a bit thrown together, but this idea works. If you push it too hard, it might fall apart, but it's useful for what we need to do for class. So I have a series of drawings. Let's jump in and take a look.
Okay, so the first thing I want to do is actually define beauty, at least to a certain degree. And you can see up here at the top of the screen, basically say beauty equals emotional perception of value. So that's my starting point for how to define beauty. Now, a few things. That seems a little cold, perhaps. I'm just saying beauty equals value, essentially, if I were to shorten it. Isn't beauty supposed to be romantic or something that's hard to grasp and all these things, and I'm putting a value on it, like making it very sort of almost monetary, as we'll see here in a moment. And I'm like, yeah, but you know what? That definition is useful. It's going to be useful for this presentation. I think it has a lot of truth to it. Now, to be honest, do I think it's the entirety of how beauty is defined? No. I think there are many different aspects of beauty. Beauty's complex, just like many human things are. But this can get us very far. And this definition of beauty actually allows us to study the concept differently than some of the other definitions do. It has some value to us as designers, especially as educators, where we have to explain things because value is explainable. So here I got this little drawing. I have the brain up here on the top right with glasses, seeing an architecture we typically use. Vision the most, arguably, but any of the senses really work, I think, can be described by beauty. And basically, things that we agree that are beautiful, they tend to be around this concept of value, particularly how were they valued for us through an evolutionary standpoint, like what was valuable to us when we were hunter-gatherers, what is valuable to us today, and even what was valuable to us in other animals long, long, long ago in the past. So I have a bunch of things along the bottom that the brain sees and makes subconscious interpretations about their value structure, and many of which we find valuable. So, for example, shelter. I have a tree here, again, sort of looking further back in the past than we typically live in now, but certainly homes and buildings can be quite beautiful. And the bigger, the more decorated, we often say, hey, those are more beautiful. They happen to have more value as well, right? Bigger homes, more expensive homes. We see those things as beautiful. So shelter, snacks, food, I think is the least one to taste it. I find the least connecting to visual beauty, but I think it's an important part of this. Sex, of course, I think is a huge one. Just seeing a mate. There's two things here. So we see people, and someone who is beautiful to us is fundamentally a valuable mate. What does that mean? They will give us good children that will hopefully last and spread our genes, right? There's direct value there. There's also a second meaning, which starts to get over to the stuff category that I have here on the right, which is just generally people who are more wealthy are perceived as more beautiful, and that's been shown in many studies. And so things that are expensive, like a race, not a race car, but a fancy car. I'm not a car guy, obviously, myself, but they're more expensive. They appear to be more beautiful than cheap cars or rundown cars or things like that. And that's because we see, like, oh wow, like a Tesla is very expensive. You can get a Lamborghini even more expensive. Wow, that is so beautiful. So we subconsciously make value judgments and then interpret those as beauty. And I want to make another point on here before I move on, which is the bottom line here. I say symmetries and proportions. What I'm trying to say is all of those categories really, not only do they have value, but this is going to be important moving on. They also have certain kinds of symmetries, patterns, proportions, geometric shapes, however you want to define it, that makes them look more beautiful. So, for example, the human face is symmetrical, and that is deemed to be more beautiful. than asymmetrical faces. But there are also certain shapes that go into the human face that are more beautiful than the standard. It's expected to look this way, or an apple, as I have here, is expected to look this way. This sort of almost heart-shaped apple looks better than a funky apple that could potentially grow, just because it's supposed to be that way. Or things like shelter and trees. Certain trees look more beautiful than other trees. I don't want to go into all the details, but certainly even in landscapes that provide shelter, there are ones that have the right shape because we sort of grew to expect those as being good shelter places, that are even above and beyond. So one way that our brain uses subconsciously to interpret value is actually the geometric form. And that's what I'm trying to say. Now, again, I'm not trying to say that this is the only key way to get to beauty is through this value lens, but I think it's one way, and I think it does solve certain things where we can make things beautiful, like we said here, but also explains things that I find interesting too, like the experiments where people are taste testing wines, and they're the same wine, and they're saying this one's expensive and that one over there is cheap. Which one do you like better? Almost always, it's the more expensive one. And again, that's just evidence that using our senses really make value judgments on things, and that's how we determine what is good or not good in many cases. And once you sort of accept this sort of non-romantic fact of beauty, we can use it to our advantage, and that's basically what we're going to look at through the rest of this presentation here, and ultimately bring it down through computers. So the one thing I wanted to talk about is, since I'm an architectural designer and this is a digital design course fundamentally, I want to talk about value and design. So if beauty equals value, then how can I get to this in design? So over here on the left, and again, this is just a summary chart. There's no scientific data going into this graph. It's just thoughts to get to sort of prove a point. So over here on the left, I've got design principles and patterns. That's what I'm going to talk about moving forward in the rest of the slides here. And basically, I'm saying, look, there's actually three ways when you understand design principles, and I like to talk about it through patterns. There's actually three things that bring in value, which makes them beautiful. Right. So the first is, it just takes time. Time is money. That's what I say right here. Right. So to actually use design principles and use them well, it takes a lot of time to design, iteration. Right. And so we can look at things, I believe, we can look at things in the world and say, wow, someone designed that. This is all subconscious, mind you. But we can say, we know when someone designed something well, and we respect that someone did that. We respect the value that's inherent in the time that it takes. Furthermore, often using a very similar concept, but often using design principles takes skill. Fundamentally, skill is in short supply, right? Frank Gehry, someone like that, can charge a buttload of money because there's only a few architects out there, right? And they're using certain design principles and patterns when they design. So to get a handle on those particular ones, you're spending a lot of money on that. That's recognizable. And then finally, I have this sort of evolutionary aesthetics one. And that sort of goes back to the previous slide, which is, I think our brains are sort of built to recognize certain things as beautiful, and that those value judgments are often being made on patterns, and those things might have started with trees or people only, but our brain sort of applies those same concepts to anything. Certainly landscapes could still be beautiful in either case, and shelter is beautiful in any case, but those things could be houses, they could be paintings, they could be anything, and it's looking at those patterns, looking at those geometries that are found in nature, which is symmetry, the golden section perhaps, in all of those things is built in as a shortcut to determining certain value functions, and those are still sort of built into us. Again, it's not the only reason. There are many other reasons that you can get the value in beauty as well, but it is certainly one reason, and one reason that we can exploit. Right. So I do think using design principles and using this pattern concept in design conveys value, and value conveys beauty. It's a way to beauty. So I want to go through the rest of these quickly. The main focus there on design principles. Fashion and style, I could have lumped it in together, but I wanted to bring it out just to talk about it slightly separately. Obviously, someone who's designing something in style, I use Frank Gehry as an architect. Previously, they are very skilled. I talked about that, but also it costs money. Fashion is almost always set by the rich, famous, and wealthy. If someone rich is doing it, that makes it beautiful, that makes it stylish, and that's how it always changes. And also, there's also a little bit of like, I'm doing something different, and maybe it's almost expensive because it's different, right? Because it's not in a lot of supply. No one even know if it'll work. Maybe even like clothing, like is this going to work or not? Oh, it works. You're famous. Yes, I love it. That's how fashion starts. So again, fashion is very tied to this concept of value in money as well. But it's not the only thing. You can also obviously get a great building with construction quality. It takes time to build a good building or make anything well, and it takes skill to do that as well. And people see that and they're like, hey, this is built really well. It's beautiful. That's a very common thing you can hear. Materials I could have lumped in with this. I purposely pulled it out. Of course, materials can be expensive or not. Hopefully, they're put together well as well. Construction quality is there as well, but they don't have to be. I could buy a bunch of gold leaf and throw it into a pile in the corner. That makes it expensive. It might even make it interesting, but doesn't have anything to do with construction quality necessarily. So they're related again, just like fashion and design principles. But the quality of construction can affect a building's beauty or anything's beauty, and on all those things. And I want to talk about sustainability because it's such a big topic. I'm being honestly a little cheeky here. Obviously, sustainability takes time to design properly, and I think that adds value. And I think sustainability can also be expensive in terms of materials and construction quality as well. And I'm sort of faking that here with the dollar sign below. But I do think there is this notion out there in architecture that sustainable buildings don't look good. And I think there's a specific reason that we can tie to this with this concept of beauty and value that I'm talking about here. And that is sustainable buildings, by general definition, are going to be efficient buildings. And efficiency is the opposite of sort of these things like over here, time is money and all this sort of things. Like if it's efficient, if it's saving energy, it's not throwing money away, right? It's cheap. I don't want to call it cheap because it has a different slight connotation in different ways. But the point being is it's purposely designed to be efficient. And efficiency is the opposite of fashion and design principles and sort of all these things. And I think there's a sense when you look at it like that, you can see it that way, and that's how the brain subconsciously determines it. So it is difficult to design a very beautiful, sustainable building because you're sort of starting from a lower end by definition. Now, obviously, I do believe there are good looking sustainable buildings, and they push this thing up by using all these other things on this chart and many others. But you have to be aware that that is an interesting thing and a design style I like to study and think about on the side. So the question becomes now, okay, so if design principles is a primary way to get to things that are beautiful, all we need to do now is understand design principles. And I like to do this through understanding of patterns. That's my basic, it's the simplest thing. But fundamentally, patterns are really just symmetries. And I don't always use the word symmetry. I like it because symmetries are very definable, therefore you can understand them. On the other hand, I think sometimes people misunderstand the word and it becomes too simple. So let me just go through this. I have a bunch of, there are standard symmetries, not just reflection mirror symmetry. That's not the only one. That's the standard one we think of. Reflection is the sort of mathematical way of talking about it. Mirror is the way that a lot of designers talk about it. But there are others, rotation, translation, scale. I'll go through all those in a minute. And my sort of theory here is that each of the main mathematical symmetries has or often has a specific design principle, the traditional like artistic design principle tied to it, and that are much more vague. So for example, symmetry, I would argue, equals balance in design principles. Now it's not the only thing balance could be, because balance can also deal with gravity, and there's a whole other like Gestaltian and other ways of looking at balance. But at least in this case, the simplified case, I think balance is just mirror symmetry. Otherwise, balance can be hard to understand or hard to teach. But when you can say, look, if this is fundamentally what it is, here it is. Now, it doesn't have to be like identical, but it's got to be similar. So I use the scale here because it deals with weight and it's symmetrical, this sort of scales of justice sort of thing. And there you go. And I think the interesting thing to note that in all these symmetries, I have the third line here, which is CAD tools, which is there are often tools in computer drawing, which is what a lot of this is about, that deal with this. So, a CAD tool would be mirror, as I said, is really reflection. Really using the mirror command is a way of thinking about balance. You got rotation, which I have NA for design principle, although I would argue that it's another way of balance. If I took off one of these fans here, this whole circle would be unbalanced, right? And actually there's a distinct relationship between reflection and rotation, because they're both rotations about an axis. It's just a matter of how your axis relates to your rotation angle. I might get into that too in another video, but I do think they're very similar, which is why I could have put balance there if I wanted to. Translation is rhythm. Like rhythm is so important in many things, not just music. I do find that's interesting that a lot of design principles relate between visually and music, because I think a lot of our senses and this whole idea of beauty is all tied together sort of subconsciously. Uh, but so I have the music notes here. But essentially, at the most fundamental level, rhythm is just copying something. It's the copy tool, right? And then the last one I have is scale symmetry. So I have the picture of the golden section shell here at the top, but which is a sense of proportion and scale. I put the word harmony in here. I believe proportion is similar to harmony. It's just more extended, more complex. Like in music, harmonies are about relationship of scales of notes. In visual, it's a scale or size of things. And obviously, this scale tool is very common in design tools. So I might post something more about the golden section at times as well. But it's not the only scale thing you can use. So I'm taking this and making it smaller by the same amount, making it smaller by the same amount. Golden section's one scale, but there are other scales you can also use as well. And so that's it. These are all symmetries mathematically. These are symmetries: reflection, rotation, translation, scale. They are just mirror, rotate, copy, and scale. You put those together. That's how you generate patterns. Right? Everyone has a sense of what patterns are. That's why I like the word, because like, oh yeah, I know what a pattern is. It can be many, many, many different things, but they all base off of these things. And once you know the root cause of them and why it's important, hopefully you can leverage it. And especially when you know what the tool is that you're using, that there is a computer tool that can actually help you. So these computer tools help you do design principles, which help you make patterns, which help display value, which makes it beautiful. All right. So I think pattern is really like a collection of all of these. I've got a little nice fractal over here on the left-hand side, which is really a combination of a bunch of symmetries put together, and it really makes it sort of very interesting. Now, before leaving this slide, I do have a little sort of pull-out bar there on the bottom, which is the secret ingredients of beauty. Because what I said is I do believe with what I've said so far is true, but what I haven't really talked about is sort of complexity and imperfection. I think are also sort of important, and there's a balance there. I've got this little seesaw drawing there on the bottom, that patterns should really balance complexity and perfection. And I'm sort of using the word here. It's not really using symmetrical like I'm using it above when I put that there. But when something, first of all, I do think things that are 100% perfectly symmetrical, they can be quite nice, but also sometimes I think they can be a little boring. That said, I also think things that are too simple can be a little boring as well. And the higher the complexity, I think the higher the imperfection can be. And so there's just tweaking something a little bit just makes it special, and you have to think about why is that different, and that choice was made. So I think, like, yes, you can use this simple, you can make the most simple patterns, but the more complex, not, there can be overly complex certainly, and there can be too much imperfections, but a little bit of here and there makes a lot of sense in a long run. And there's just some quick examples I don't have rights to, so I'm not going to talk about, but I think like Jackson Pollock, for example, really great painter. When you look at his work, it's very mathematical in the sense of fractal like. So I've read, and it's also complex. It's also not perfect at all. No fractals are perfect. If you want to know more about fractals, I'm sure there's lots of other videos. I'm no expert in it, but I do find them really intriguing. And his work is like that. It's complex, it's imperfect, but it's filled with pattern. Even though it looks random, it's not at all. And I think many other artists are the same way. Vincent van Gogh, like the way his brushstrokes are, there's a pattern to them. They're a little bit of complexity, and of course, it's just a human hand. It's not perfect. It's so beautiful in the colors and everything else. And the same thing is true, say, with the Farnsworth House by Mies van der Rohe, which I'm going to look at in another example. I think the modern architecture of steel and glass, I think there's a contradiction. Some people find those buildings quite beautiful, and some don't. And I think this really sort of can explain that, because a a layperson who might not know, especially in 2020, looks at that building as, yeah, there's no, it's almost too simple. I don't appreciate as much as say an architect or maybe someone from an earlier time, but an architect who understands these things, especially historically. Like, it wasn't cheap to build in steel. Those big giant panels of glass were super expensive. The time it took to actually work out all the geometries in there and do something different had to take a lot of money, and someone had to take a risk to do it. And so if you view it from that lens, you see the value and you find it beautiful. But if you don't know all that stuff, you don't see a lot of complexity or a lot of pattern in there, and you might not find it beautiful at all. It all goes back to this concept of value is beauty, and it can often be defined by patterns. So that is sort of my general secret to beauty, which is simple patterns, simple CAD tools can get you to beauty. I do have one more slide here before I finish. So I call this the beauty circuit that really pulls, just a summary pulling all together. So anyway, I started with beauty. I said beauty equals value. And one way of subconsciously internalizing that value is like understanding its pattern, its geometries. And then on the previous slide, I just showed how pattern is really just a bunch of symmetries. And symmetry is really just math, of course. And logic is very, very much more tied up in math. I got call out to Spock there. That's my logic. Of course, computers use logic, so they're basically equal. And so we come full circle that computers equal beauty. Of course, that's, again, I'm not really, this is oversimplified. Is this circular logic? I don't know. No, the reality is I'm just saying computers is one path. When you understand that there's many ways to beauty, but when you understand that one way is through patterns, you can really use a computer to get there quite easily, right? And so for the architects who are using software out there, I've got this last little chart over here on the side, which is called the value of geometric tools that allow for the easy creation of patterns and beauty. And basically, there's the vector software, which is things like AutoCAD and SketchUp, Illustrator perhaps. And then there's the BIM software, which is Revit. Photoshop is sort of, I don't really want to talk about it. It's a completely different software, but I thought I'd put it up on here. And you notice I just made up this value here, but I put AutoCAD and SketchUp and whatnot up high on this. It's like, it gets us there. And BIM, Revit, which is becoming more and more popular, actually down lower. And the reason for that is this: those tools I listed out a couple slides ago, mirror, copy, rotate command, scale command, those are all inherently function to like tools like AutoCAD or SketchUp or any other ones, Rhino, you could name hundreds of them. And they're inherent to them. Like, I sometimes do a demonstration in class where start me one line of any length, I don't care. I can draw in AutoCAD anything you want just by using the modify tools: modify, move, copy, rotate, scale, mirror, all of those things. The reason is because they're fundamental to the software and how you operate within them. So I would argue that those softwares are really connected to this concept of value. You can leverage those tools. They're optimized for the creation of beauty if you use it that way. Where BIM software is more about like building walls. They do have copy and mirror and all those things, but they're much more secondary. They're not primary. You build with walls and complexity, and I'll have another video about, or I probably already posted another video about this as well. But I think when it comes to design, it comes to beauty, vector software, because those tools are more fundamental to it, make it better, at least in early phases. And if I were to take a leap out here on the edge, and if I were to predict what the next software would be like in architecture and other design tools, it's going to be taking the smarts of this, but using those tools more fundamentally, more forward. And I think it might involve artificial intelligence in a way. Because I can draw something, I can even sketch something symmetrical and hand it off to any competent designer, and they can translate that into formal construction documents. The computer can't do that yet, but there's no reason why it can't in the future. So I think taking the smarts of BIM software and using those primary tools to get to beauty and design is going to be the next software, because we can see there's a gap there. So anyway, that's my argument. Computers equal beauty. Use the computer, use the tools to create things that are beautiful, use patterns, have fun, keep making great drawings.